Okay, so this is 1323 here, and we're given this pulley system. We know that this is F here being pulled on, and we know that's 150 newtons being pulled downward. And we also know the mass of this A here, which is 50 kilograms. Let's just turn that into a force right off the bat. So we have the weight of A equals 50 times 9.81, which is equal to 490.5 newtons. All right. So with this force downward, we're looking for the velocity of this block A when it has risen 3 meters. So when as you pull on B here with this force F, pulley C is going to move upwards, and pulley A is going, or this weight A is going to move upwards, and we're looking for that velocity at that time when A has risen or has gone upwards 3 meters. All right, so let's we know that these pulleys are frictionless and have negligible weight. So we know that the tension in these cables does not change as it passes over a pulley. So as you can see with F here, right, the tension in this cable over here will be equal to F, which was 150 newtons, which wraps around this pulley and actually wraps around pulley C as well. So let's draw a free body diagram of pulley C. So we have since we know the tension in this cable is F here, we have F going up on both sides. So we know that's 150 newtons on both sides. And in the middle here, we have a downwards force here, which is, we can call a tension 1. And if we sum the forces in the y direction, all right, take the sum of the forces in the y direction and set those equal to the mass times the acceleration of this pulley. We've already said that this pulley has negligible mass, so we set that equal to 0, and then we just have the sum of the forces is equal to 0. So T1 just comes out to be 300 newtons. Okay, and T1 here is this tension here. Okay, so let's draw the free body diagram for this pulley attached to this block A now. All right, so we have this pulley here, and then we'll have, going upwards, we have this T1, and we have T1 going up on this side, right? And remember, T1 we just figured out is 300 newtons. So going upwards, and then in the middle here, we have downwards this weight of A, which we've already found, which is 490.5 newtons. Okay, so now we're looking for what is the, I think to be able to tell what the velocity of A is when it has risen 3 meters, we have to figure out the acceleration here. We have to figure out the acceleration of A. So let's take a look at that. So if we sum the forces in the y direction, and that should be equal to the mass of A times the acceleration of A in the y direction. I guess we should put that in the y direction. In the y direction. Okay, so the sum of the forces in the y is positive. We have 600 upwards, 300 and 300, and we have 490.5 in the negative direction, and that is equal to the mass of A, which we already know is 50 kilograms, times the acceleration. And I'm just going to say the acceleration in the y direction here. All right. So solving this equation, we have the acceleration in the y direction. That comes out to be 2.19 meters per second squared, and that is upwards. All right, so that's something we should note. Now, how do we transform a acceleration into a velocity, and then we're also given a distance. And maybe you remember the equation v squared equals v naught squared plus 2ac s minus s naught, right? So if we know the acceleration is a constant here, we can use this equation. And we're given what s and s naught is. So s naught is 0, s is 3 meters, and then we've just figured out the acceleration as 2.19 meters per second squared. And I think in this problem we're given that it starts from rest, so our original velocity is 0. And if we solve this equation now, we only have one unknown, and the velocity comes out to be 3.62 meters per second upwards. Right? And that is our answer for 1323.